Hi, this is Scott. I wanted to just quickly make a video to explain how to build crystals or how to model crystals with vZome. The first step to do this is really usually to switch to the octahedral system. Most of the common examples of crystals you want to build will be related to or use a cubic lattice. That's much easier when you're in the octahedral system. You don't have to fight with green directions, green struts and yellow struts that aren't within the system. So let's build a quick cube. So I'm going to apply cubic symmetry to one ball there. And now I'm going to construct the 3D convex hull with struts only. Okay, so now we have a cube. This will be the unit cell. And I'm going to get rid of that yellow strut. So one way to do this is with tools, and I'll show you a different and maybe easier way shortly. But let's start with the tools. So suppose I want to make a copy of this cube on the right side here. So what I can do is I can build a tool that will translate anything one blue strut to the right, okay? And to do that, I simply have a starting ball and an ending ball, and now I see, as soon as I have those two balls selected, my translation tool factory button is enabled, and I click on it and I get a translation tool here. If I right click on that, I'll see that this tool is actually going to delete its input. So let's leave it like that and see what happens. So I'm going to select all except for the center ball, and now let's apply the tool. So it's simply moving the thing to the right. So let's undo twice. I don't really want to move it, I want to copy it. So I'm going to turn off delete. And now if I apply it, I'm actually making copies. So once you've made a tool like that, it's pretty straightforward. So let's make the tool in two other directions. And again, I'll turn off the delete. And let's go from here to here. And turn off the delete. So now I have sort of an X, a Y, and a Z tool. So we've already done our X repetition. Let's do our Ys. Well, I guess that was Z's, and let's do our Y's now. Okay, so that makes it pretty quick. Setting up a tool is a little bit awkward, but once you have it, it's very quick to make repeated structures. So let's find another way to go about this. So I'm going to undo and redo just until I'm at my cube. All right. Somewhat simpler and more intuitive to do is to use copy paste. But there's a subtlety here. Normally, if I copy something, I just say copy, and then I'm going to pick a ball and paste it. Actually, let's just even use the center ball. If I paste this, it ends up somewhere. Why did it end up there? Well, the copy paste behavior really wants you to select the objects in a certain order. But in fact, all it cares about is the last object selected, the last ball selected. So again, I'm going to select all, deselect that. I'm going to deselect this ball and then select it again. So now this ball is the last one selected. So now if I say copy, now I have some control. I can paste it here, or I can paste it here, again here, etc. I can have very good control over where I paste it. It's always using wherever the single ball I select is where it pastes it. Okay, so if you can understand that selection behavior, you get a very powerful capability. But let's just use it to make the periodic cubic lattice like a salt crystal. So I'll simply do this: paste, click to deselect, click to select, paste, deselect, select, etc. So it's not quite as smooth and quick as the translation tools, but it is in some way more intuitive, perhaps. So now I'll do the other thing. I'll copy again, determine my origin, copy, paste, paste. And finally, I'll select all and copy and paste. Okay, and there you have it. So there's another way to create a periodic structure. Now let's do something a little bit more challenging. Let's try to make a diamond lattice. So I'm going to once again create my cube, except this time I'm going to keep that strut, and I'm going to apply tetrahedral symmetry. So there's my carbon atom. And in fact, what I want to do is I'm going to color these carbon atoms black. Okay, just to make it clear that we're only using half the balls in the cubic cell. And it should also make it clear that there's really no value to, let's select the things. And if I say that's my copy origin, there's no real value to connecting it here, because that's not a carbon atom. That would be a vertex in a parallel diamond lattice, but we don't want that. We want just the regular diamond lattice. So I'm going to paste it here. So now I'm going to be translating along the diagonal. So I can paste it there, do it again, and again. And now let's get rid of my cube lattice. And I'm going to select all, choose a different origin, copy, and now we're going to go this way. Paste, 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 and finally I'll select all. Let's go this way. So that's my origin, copy, paste, paste, paste. Okay. So there we have our diamond lattice. Okay, so hopefully that gives you some insights into how to make periodic structures with vZome. There are other lattices or other crystal structures that'll be a little bit more challenging. But ultimately, if you can find the unit cell for the crystal, then you can always use these techniques. Thank you.